Now we're going to take a look at conditional probability, which we've actually already seen with dependent events. So this is just more practice on that conditional probability or dependent events. And as we've already seen, the probability of A and B is the probability of A times the probability of B given that event A has already occurred. All right, our first example is with drawing cards from a deck. So what's the probability of being dealt a king and then another king? So we have 4 kings in the deck, remember, one of each suit, hearts, diamonds, clubs, and spades, and there are 52 total cards in the deck. And then another king. Well, now that we've pulled one out, there are 3 kings left and only 51 cards left. Simplifying, 4 goes into 52 13 times. You can remember 4 times 13 is 52 because of the 4 suits and the 13 cards in each suit. And 3 goes into 51 17 times. So we have a probability of 1 out of 221. Our next one has to deal with the sample space of rolling 2 dice. Now what you're going to want to do is know what this sample space is. So make sure that you jot this down. I believe that I actually put it in the notes for you. Make sure you have access to this, you know where it is. Hint, hint, this is on your test, knowing or at least being able to generate this sample space. So what we have here are 2 different colored dice being rolled. So notice the white die, all of the different options coming up, and then the red die, all of the different options coming up. This one we can simply use the sample space. We don't even need to multiply probabilities together. We can just count our options. What's the probability that the red one is a 6? So that narrows it down to this last column here. We already know the red one rolled a 6, so those are our only options so far. And the sum is greater than 9. Greater than 9, not equal to 9. So that excludes those first 3 options. So now we're down to just these 3. We could roll a 6 and a 4, a 6 and a 5, or a 6 and a 6. That gives us a probability of 3 out of 36 total options. That's 6 by 6. Simplifying, we get a 1/12 probability.